Does Python optimize tail recursion? I have the following piece of code which fails with the following error. Runtime error, maximum recursion depth exceeded. I attempted to rewrite this to allow for tail recursion optimization, TCO. I believe that this code should have been successful if a TCO had taken place. Should I conclude that Python does not do any type of TCO, or do I just need to define it differently?
No, and it never will, since Guido van Rossum prefers to be able to have proper tracebacks. Tail recursion elimination, the 22nd of April 2009. Final words on tail calls, the 27th of April 2009. You can manually eliminate the recursion with a transformation like this.
I published a module performing tail call optimization, handling both tail recursion and continuation passing style. This URL. Optimizing tail recursion in Python. It has often been claimed that tail recursion doesn't suit the Pythonic way of coding and that one shouldn't care about how to embed it in a loop. I don't want to argue with this point of view. Sometimes, however, I like trying or implementing new ideas as tail recursive functions rather than with loops for various reasons, focusing on the idea rather than on the process, having 20 short functions on my screen in the same time rather than only 3 Pythonic functions, working in an interactive session rather than editing my code, etc. Optimizing tail recursion in Python is in fact quite easy. While it is said to be impossible or very tricky, I think it can be achieved with elegant, short and general solutions. I even think that most of these solutions don't use Python features otherwise than they should. Clean Lambda expressions working along with very standard loops lead to quick, efficient and fully usable tools for implementing tail recursion optimization. As a personal convenience, I wrote a small module implementing such an optimization by 2 different ways. I would like to discuss here about my 2 main functions. The clean way, modifying the Y Combinator. The Y Combinator is well known. It allows to use Lambda functions in a recursive manner, but it doesn't allow by itself to embed recursive calls in a loop. Lambda calculus alone can't do such a thing. A slight change in the Y Combinator, however, can protect the recursive call to be actually evaluated. Evaluation can thus be delayed. Here is the famous expression for the Y Combinator. With a very slight change, I could get instead of calling itself, the function f now returns a function performing the very same call, but since it returns it, the evaluation can be done later from outside. My code is the function can be used in the following way. Here are 2 examples with tail recursive versions of factorial and Fibonacci. Obviously, recursion depth isn't an issue any longer. This is of course the single real purpose of the function. Only one thing can't be done with this optimization. It can't be used with a tail recursive function evaluating to another function. This comes from the fact that callable returned objects are all handled as further recursive calls with no distinction. Since I usually don't need such a feature, I am very happy with the code above. However, in order to provide a more general module, I thought a little more in order to find some workaround for this issue. See next section. Concerning the speed of this process, which isn't the real issue however, it happens to be quite good. Tail recursive functions are even evaluated much quicker than with the following code using simpler expressions. I think that evaluating one expression, even complicated, is much quicker than evaluating several simple expressions, which is the case in this second version. I didn't keep this new function in my module, and I see no circumstances where it could be used rather than the official one. Continuation passing style with exceptions. Here is a more general function. It is able to handle all tail recursive functions, including those returning other functions. Recursive calls are recognized from other return values by the use of exceptions. This solution is slower than the previous one. A quicker code could probably be written by using some special values as flags being detected in the main loop, but I don't like the idea of using special values or internal keywords. There is some funny interpretation of using exceptions. If Python doesn't like tail recursive calls, an exception should be raised when a tail recursive call does occur, and the Pythonic way will be to catch the exception in order to find some clean solution, which is actually what happens here. Now all functions can be used. In the following example, fn is evaluated to the identity function for any positive value of n. Of course, it could be argued that exceptions are not intended to be used for intentionally redirecting the interpreter, as a kind of Godot statement or probably rather a kind of continuation passing style, which I have to admit. But, again, I find funny the idea of using try with a single line being a return statement. We try to return something, normal behavior, but we can't do it because of a recursive call occurring, exception. Initial answer, August 29, 2013. I wrote a very small plugin for handling tail recursion. You may find it with my explanations there, this URL. It can embed a lambda function written with a tail recursion style in another function which will evaluate it as a loop. The most interesting feature in this small function, in my humble opinion, is that the function doesn't rely on some dirty programming hack but on mere lambda calculus. The behavior of the function is changed to another one when inserted in another lambda function which looks very like the Y Combinator. The word of Guido is at this URL. I recently posted an entry in my Python history blog on the origins of Python's functional features. A side remark about not supporting tail recursion elimination, tray, immediately sparked several comments about what a pity it is that Python doesn't do this, including links to recent blog entries by others trying to prove that tray can be added to Python easily. So let me defend my position, which is that I don't want tray in the language. If you want a short answer, it's simply unPythonic. Here's the long answer.
Python does not and will probably never support tail call optimization based on Guido van Rossum's statements on the subject. I've heard arguments that it makes debugging more difficult because of how it modifies the stack trace.
If you want to see more, please consider subscribing.